Hello and welcome back to Waveform Science. I am, as always, your host, Jeff Hagan. At this point, Bluetti has started taking pre-orders for the newest of their large solar generators, the Apex 300, in their portable line, sort of portable because of how big they are. They can scale up to the size of most, if not an entire house, or they can be used standalone in an off-grid situation. So we're going to spend the next hour or so poking at it, taking tests and seeing how well it behaves. But before we do any of that, what does it come with in the box? Well, it comes with a instruction manual, QC card, a AC power cable, very nicely computer power cable style, a car cigarette lighter cord, which is probably going to take forever and a day to charge from because those are limited, and a little baggie with a grounding screw in it. And that's it. Interestingly, it does not come with solar cables. Now, it does use standard solar cable inputs, so I'm not too worried about the fact that they didn't put the cables in the box, but yeah, it's not in the box, so that's interesting. The things that the Apex 300 can do, what makes this different? Why did they replace the AC 300 is really the question. Apex 300 has two inverters inside, and it can make US split phase power. We're going to go into more details later on what that means. But the other claim to fame that it has is it is one of the very few solar generators on the market that can charge from 120 volts while making real 240 volt split phase power with two different 120 volt signals. Meaning that you can run off of a 120 volt generator into the Apex 300 and run the output of the Apex 300 into a transfer switch that requires 240 volts. So that gives you huge flexibility. By the way, it can also do the reverse. It can generate 120 volt power when it's charging from 240. Cool stuff. So let's take a look at it and run it through a bunch of tests and see what it does. What are the dimensions of the Apex 300? We are looking at about 20 inches by about 13 inches. And if we rotate over to the side here, depth is about 12 inches or so. Manufacturer says 20.7 by 12.9 by 12.6. So 20 by 13 by 13 roughly. That gives us a cubic feet in volume of 1.9 cubic feet. And yes, this is a US-centric channel, so 1.9 cubic feet. Energy density by volume. Let's take the watt hours of the unit and divide by the volume in cubic feet. We get 1,420 watt hours per volume, which actually is very good. Let's compare this to the AC200L, where we get 1,365, so it's actually more dense than the AC200L. It is not practical to really compare this to the Elite 200 because that one does not have battery expansion capability. So that's why that's not on the list. Of course, we need to compare it to the AC300 and the AC500, where the AC300 is effectively the same size head unit for the 300 and the 500 as the Apex, but the 300 and 500 don't have a battery in it. So you have to add at least one battery to the dimensions of the AC300 and AC500 to make it a fair comparison, which then reduces your energy density by volume by about half. So the Apex 300 is, my math says, 47% more efficient by volume than the AC300 and 48% more efficient than the AC500 by volume. As far as weight, Apex 300 is heavy enough to be a team lift required device. We're looking at 83.8 pounds according to my scale, which lines up pretty much exactly with what Bluetti says is 83.78. That's down to just the calibration of the scale at this point, so right on it. Basically means the Apex 300 is a team lift. One person alone moving this is not going to cut it, and if you've got to go up and down stairs, yeah, you're going to need a cart of some kind to get this thing up and down stairs. But it's got handles on the front, on the sides here. And you can have one person grab one side and one person grab the other side to move it around. But just be aware, if you're only one person, it is somewhat dubious to move this thing around without wheels on it. That being said, it's still more efficient by energy density by weight than their competition models. If we compare it to AC200L, which is, by the way, significantly lighter, but also significantly less battery in it, we get a 33, which is watt hours divided by pounds. So that's watt hours per pound. And Apex is 33.0, so effectively the same as the AC200L. AC300 and AC500, however, are dramatically less efficient by weight, again simply because they were unable to put the battery in the same box as the head unit on those devices. The head unit doesn't have a battery in it. But yeah, if you decide to get an Apex 300, get somebody to help you carry it up onto the table, because this was hard. Physical controls, ports, and connectors. What do we have on the Apex 300 as far as that is concerned? We have 4 AC outlets of your NEMA 520 20 amp outlets. You will notice that they are marked 1920 watts here, 1920 watts here, and 3840 watts there. We're going to explain what that means in the next section, but first let's just go through where the connectors are. So we've got 4 outlets on the front. We have some switches. By the way, the first Bluetti in a long time that has physical switches on it. First one is a 120/240 voltage selector switch. Again, we'll cover that in the next section. Eco mode turns eco mode on and off. Push the button, it lights up while you push it. When you let go of it, the light goes away, but it does change the icon on the screen. Turn it back off right here. AC turns on and off the AC output. Charging mode, silent mode, auto mode, and turbo mode. You can flip the switches. And yes, as another first for Bluetti device, there's a child lock that can lock out the buttons. So if you've got kids around and they're going to push the buttons while you're not looking, you can actually go in the app and make it so they can't do that. We've got one of the newer style Bluetti screens, which has everything you need to know on it, and it does show 120 versus 240. It shows you how that switch is set. There is both Bluetooth and Wi-Fi icons on the screen to show you when that is active. If I turn the device to the side, we have a little screw here, which can be removed, which can then let you take off this cover right here to get to the air vent. So if you have animals and you need to clean your air vent, this actually can be cleaned. And there is an air filter in there that can be cleaned. We have 2 ports here. We have a battery expansion port, the standard P090D port that Bluetti has now been using going all the way back to the AC200 Max. Same port. And we have 2 XT60 jacks right here, which are used for solar input. And we'll cover the solar input in a later section, but that's where the connectors are. On the back of the device, we have a big sticker and some screw holes. Similar to the B300K battery, they have put mounting holes on the back of the device. So if you were to build a bracket, they do not provide you with a bracket, but if you were to build a bracket, you could actually bolt it to the wall. Nice. Helpful for us in earthquake areas. Next side, we have a few things here. First off, we've got our grounding port, which we'll make sure that's hooked up properly in a couple minutes. We have an AC input plug, which nicely uses a standard computer power cable. So easy to find. No custom ports needed for that one. Custom plugs, rather. We have a circuit protector in case it ever pulls too much power. It's got a circuit breaker in there to prevent it from blowing things up. We have an AC in and out port. This is something new and different. The AC300 and AC500 have the input side and the output side strictly delineated. There is an input, there is an output. The input comes from your power adapter, power source, and the output goes to your transfer switch. This sort of blurs those lines, and until we get to talking about the accessories, you're not going to see how that works too well, but it has a custom plug here. So yeah, you'll need a Bluetti accessory to use this for anything. This, by the way, is where your 30 amp and 50 amp charging cable plugs in, the 30 amp being a 120 volt and the 50 amp being a 240 volt. We have an AC output, 120 volt 30 amp max. This is a TT30 RV slot socket. It is marked 30 amp max on here, even though in certain configurations you can't actually get the full power out of it. We're going to cover that in the next section. Same thing here, we've got a 50 amp plug, 120, 240. This can actually output 240 volt split phase depending on how the device is set. But again, it says 50 amp max here. This does not have a 50 amp inverter in it. So you're never going to get 50 amps out of this, even though it says 50 amps, because just the inverter is not big enough, is what it is. All right, back around to the front. To cover the elephant in the room, notice there are no DC outputs. None. There isn't even a cigarette lighter jack. There is nothing DC on this device. If you wanted to use DC with this device, you would need to purchase the D1 hub here, and you could plug this in, by the way, to the battery expansion port. That's how this plugs in. And this will be a separate video because this on its own is useful without the Apex 300. So yeah, this is interesting enough that it's getting its own video. So we're not going to cover the D1 hub too much here. So just be aware, there are no DC outputs on the Apex 300. If you're expecting to charge a cell phone or charge an RV for 12 volts, or 24 volt RV, if you need DC output, this doesn't have it without buying the expansion box. And that will be another video. I'll do a video on that. Next, before we get into the testing, let's discuss what makes the Apex 300 significantly different than non-Apex 300 models. And this, by the way, is specific to the US market. The US market version generates what we call split phase power. Split phase power has been around since the early 1900s in the United States. And it's been around for that long simply because we have one of the oldest power grids of any country. And because we have an old power grid, we have some wonkiness. So one of our wonkinesses that we are now stuck with, because once you make a standard, the standard tends to not go away, is that we send in two different 120 volt signals at 180 degrees out of phase, instead of sending in one single 240 volt signal like Europe does, which is simpler and you can get more power out of the same outlet, but we just don't do that. We have some devices in our house use 120 and some use 240. So how do you get 120? Well, you've got two different 120 volt circuits coming in to your house generally, and some of your outlets are running off what's called L1, that's your first line, and some of them are running off what's called L2, which is your second line. And to get 240, you run the positive off of L1 and the negative off of L2. And of course, you've got a ground pin as well. And L1 to L2 gives you 240. L1 to neutral gives you 120. L2 to neutral gives you 120. Might be too quick, but there's a lot of videos on exactly how this works that goes into more depth. So if you want to see why we have split phase or how it works, that could be further research. But the short version is this device makes split phase power, which in order to make split phase power means you have to have either two inverters or a whole lot of transformers. And two inverters weighs a lot less than a whole lot of transformers. It's also significantly more efficient. So what you actually have in here is you've got one inverter on this side, which is a 1,920 watt inverter, 1920 watts, which interestingly is smaller than the AC200L. It is smaller than the AC240. It is smaller than the Elite 200. So this is a relatively small inverter, but you have two of them. You have a 1920 watt inverter and you have another 1920 watt inverter. So these two outlets are running off one inverter. This is the L1 inside the device. These two outlets over here are running off of the L2 inverter. So you could run, and we'll demo later, a toaster on this one and something else on that one. Or a hairdryer and a toaster, two different appliances at the same time, because the two inverters are running in opposite or non-opposite frequencies. There's a switch here that says 120, 240. What does this switch actually do? Well, when it's set to 240, like I have right now, you're going to be generating split phase power. So your L1 and your L2 are going to be 180 degrees out of phase with each other. In other words, all these outlets are turned on, but they're 180 degrees out of phase. For these two versus these two. That doesn't actually hurt your appliances. It's perfectly fine. You can plug an appliance in over here, you can plug an appliance in over there. No problem. It doesn't hurt the appliances to have the power be out of phase because that's actually how your house is set up normally anyway. Okay? When you have your house, half your circuits are running off L1, half your circuits are running off L2, which is actually why they did this in the first place, because when you go to actually run your house off of this, there are challenges, fire hazards generally, if you try to run a house that's wired up for 240 off 120 only. There's a selector switch here. If I select the switch to 120, like that, now it says 120 volts on the screen. What happens inside? The two inverters are now going to switch, and they are going to be connected together in phase. In other words, now they're going to both make the same frequency. So this and this is going to be exactly the same. And it connects a relay inside the device that actually connects the output of the two inverters. So let's say I want to run a 3,000 watt well pump or a 3,000 watt induction burner, which you're going to see in a couple of minutes. How can you do that? Well, my inverter's not big enough in 240 volt mode. I only have 1920 watts per side. But if I want to run a 3,000 watt well pump, that's a 120 volt well pump. How can I do that with this device? Well, you can. You flip the switch to 120. Now, you're not going to get 3,000 watts out of this outlet. But you can get 3,000 watts out of this outlet, because that's a 30 amp outlet. So you can actually max out the TT30 port here if you flip the switch. If you don't flip the switch, you are limited to 1920 watts of 120 volts for a single device, because you don't want to connect this one to that one when that switch is in 240 because they're out of phase. If you want to run multiple smaller appliances, flip it to 240. Now you can run one appliance over here and one appliance over there. We're talking high power appliances here. We're talking heaters, we're talking coffee makers, we're talking hair dryers, things like that. You can run one on this side and one on that side. No problem at all in 240 volt mode. If you want to run a 240 volt appliance and you want to run a single 240 volt appliance, like, for example, this aforementioned 3,000 watt induction stove that I've got running right here. If you want to do that, then you have to be in 240 volt mode. Because if you're set it to 120 volt mode, there is no 240 volts coming out of the machine anywhere. How can you get at the 240 volt output? Two ways. First way, of course, the easy way, use the 50 amp plug. Your L1 and L2 will be these two right here. Top one to the bottom one, that'll be 240 volts. That's your neutral, that's your ground. And when you're in 240 volt mode, you're going to get 240 volts out of this. You'd plug your 240 volt appliance in here, or, by the way, your household transfer switch. The one thing to be careful of, though, when this is switched into 120 volt mode, because it bridges the two inverters, you're going to get 120 volts out of these outlets and 120 volts out of these outlets in phase. But you're also going to get 120 volts on this one and 120 volts on this one in phase, which actually is not technically allowed under our US electrical code. So be very careful if you decide to hook up a transfer switch to an Apex 300. You need to make sure that this is set to 240 volt mode before you plug into your transfer switch and before you turn the AC power on. Otherwise, you could potentially damage the house, because the way they have this wired up today, this port right down here isn't quite hooked up the way that you would expect it to be when it's set to 120 volt mode. Not a problem at all as long as you're in 240 volt mode, which you should be anyway if you're connecting to a transfer switch, set it to 240. So that was a bit complicated with the 120 240. So how do I recommend actually having it set? In general, my recommendation is going to be leave it set to 240 all the time unless you have to flip to 120. What do I mean by that? If you have an appliance that will not start, you've got a 12-inch miter saw. That's the one I have to flip it for. You have a 12-inch miter saw that is a 120 volt device, but it just won't start if the device is set to 240 because it pulls too much power. What do? You flip it to 120 with nothing else plugged in, obviously, when you do that, and use your single appliance that draws too much power. But I would say 99% of the time, you want this thing flipped to 240 volt mode, because that's really what this is designed for. If you're doing huge loads that are 120 volt only, really the AC 500 is something to consider there. But if you're doing home backup, where you're running a lot of smaller appliances, that's really what this is designed for, and that's really what the 240 volt mode switch is for. So I would leave this in 240 volt mode pretty much all the time, even if I'm only running 120 volt appliances. That's a critical bit. Even if you're running 120 volt appliances, leave this in 240 volt mode. That's what it's designed for. Okay? That's how it works. Next, let's talk about the built-in solar inputs. And of course, I have benchmarked them. The amps stay low, below about 18 volts to prevent you from blowing out your cigarette lighter port in your car. Pretty much all Bluetti units do this. And then it goes up linearly until you get to the maximum of 60 volts. It stays at the full amperage. They advertise 20. My meter says 21.5 amps. Until you get to 1200 watts as displayed on the screen. However, and this is where the benchmarking is going to take a bit of a turn, this number is not achievable in the real world. And there are some folks that are grumping a bit about the solar input, and I think with good reason. This is being advertised as a 1200 watt solar input, but you're never going to see 1200 watts in the real world. The reason for that is that your solar panels, first off, if you are in an area that goes below freezing, you have to have a 20% overhead to account for the fact that solar panels make 20% more voltage when you go below freezing. So we're going to take the 60 volts multiplied by 0.8, 80%, take 20% off the top. Then the difference between your open circuit voltage, which is the voltage on the solar panel when there's no load on it, and the maximum power voltage. That's the voltage on the panel when the panel is being used under its maximum amount of power. The difference between those two numbers is about 20%. And remember, you have to have the highest voltage. You can't go above the highest voltage. So that means you lose 20% times 20% off of the maximum voltage that is acceptable into a solar input. And that gives you your working voltage for your solar panels. That comes out to 38 volts, 38.4 volts, if I remember my math correctly. I have my meter here set to 38.8. And if I turn this on, we're going to start pulling power out of the power supply. We'll get up to 21.5 amps, which is what I measured it pulling. And you can realistically see 790 watts. That's as much as you're actually going to see from the solar input on the Apex 300 given real-world solar panels. That's assuming you have to worry about going below freezing. You'll get up to about 1,000 watts if you don't have to worry about going below freezing. But the vast majority of the United States, and this is a US-centric channel, the vast majority of the United States does have to worry about that at some point. So the reality is you're never going to see 1,200 watts out of this. They presented this at CES, and we all kind of had the same feedback, honestly. And the feedback that we got from them was that they were really trying to fit the battery in the box. And that was really the challenge, is the physical size of the battery uses so much space. And they couldn't fit that big of a solar controller in there. Their answer to the question was this breakout solar box. The Solar X 4K. That's going to handle a solar panel going up to 550 volts, if I've read the spec sheet correctly, and should provide up to 4,000 watts of solar, which is, plenty. I mean, that's a good thing. But it's a breakout box, not built into the unit. And the reason they did that is they wouldn't be able to fit the battery in there if they had put a bigger solar controller inside the box. Kind of the same reason there's no DC outputs on this. A couple of trade-offs here. Do we want a battery in the box versus having breakout boxes? All right, UPS mode testing. I have the Apex 300 here set up. I have the standard AC power cord here running to a switch so I can turn it off easily. I have it plugged into the front of it. I have this cord that's going into my meter. That's going to record the AC waveform. I have this cord, which is just a DC wall wart that has a load on it. That's going to act as my trigger to tell the oscilloscope when to take a reading. As always, do not measure AC mains voltage from an oscilloscope that is also plugged into AC mains voltage unless you want to get zapped. This particular oscilloscope is running off a battery, And it's not the same battery as the Apex 300. It's got a battery built in. So let's capture how long it takes to actually switch over. All right, we've got a good capture. Let's take a look at it. Okay, the yellowish line, that's our AC waveform. The blue line that drops out and then comes back, that's actually the trigger that's coming off of the wall wart. So we can ignore the blue line and just worry about the yellow one. So let's do a measurement here. A cursor, type channel 1 voltage. Oh, I want type time. There we go. Okay, so from A, put that there. That's about when the waveform starts going wonky. To B, right there. That's about when it starts to recover. We are looking at A to B right here is 12.6 milliseconds. So in this particular case, according to my oscilloscope, it took 12.6 milliseconds to switch over. And as before, 12.6 milliseconds is plenty fast enough. Your appliances in the United States are generally designed with the ability to lose power for about 20 milliseconds before they actually reset. So that's about half the time that they actually have in their spec. They advertise 20 milliseconds. So yeah, 12.6, pretty good. Now remember though, there are two inverters. There's the one on this side and there's the one on this side. The other thing to remember is that Bluetti advertises a 0 millisecond split time in some cases. How does that work? Well, let's measure the other inverter. Let's see what that does. All right, so I've set up for the other inverter now. Plugged into this side here. You can see all I did was move my two plugs over a little bit. Bump the thing. Made it take a measurement. Oops. Yeah, you got to be careful not to bump it. It's a little sensitive right now. So this is we've got green here. That means it's ready to take a measurement. Let's cut the power here and see if it has a trip time. And interestingly, it doesn't. See, it's still green. I don't want to bump it because it's going to take a measurement if I move this little connector here. But it didn't actually take a measurement. And why not? Because I did trip the power. Let's set it up. I'll do it again. All right, we're set back up. We're charging again. We've got the meter ready to take a measurement. Let's cut the power again. And nothing. It's still ready to take a measurement. It didn't trip. So what's going on here? Why is it not taking measurements for my UPS switchover time? Well, the answer is there is no UPS switchover time. It is a 0 millisecond switch, so there is nothing for the meter to read. What does that mean? Let me turn it off here. See, here's my readout when it goes to 0 when I turn the output off. So what does a 0 millisecond switchover mean? It means it's not switching. It's already running from the inverter. Why is it already running from the inverter? Well, the input power here, it's going into the side of the device, is being passed through, just like your 120 volt Bluetti devices. Your AC200L, your AC240, all those devices. And that's being passed through on this side. So when I lose power, there is a relay on this side of the device that actually physically switches that gives me a switchover time. This side of the device, however, is generating an AC waveform that is 180 degrees out of phase with this one, meaning this waveform isn't coming in from this power cable. It's being generated internally all the time. In other words, it's running off the battery all the time, even when it's plugged into power, because it has to, because it's charging off 120 and it's generating 240. It doesn't have this waveform inbound to switch off of, which means in this case, this is running off the inverter all the time, so there's a 0 millisecond switch time because there is no switching going on. When the power comes off, the only thing that stops happening is the battery stops charging. It was already running off the inverter, so there's no switching. So if you've got servers, if you've got sensitive laboratory equipment that absolutely cannot have a UPS switchover mode, this side here, this side, when you're charging off 120, is running off the inverter all the time anyway, so there is no UPS switchover time. This side over here does have a UPS switchover time when it's running off 120. Now let's talk about what happens if you charge it off 240. I don't have that cord, so I can't actually reproduce it because Bluetti didn't send me the cord yet. But if you had a 240 volt cord, then presumably it would pass through 240 on this side and 240 on that side. I don't have a way to test that right now though. But presumably that would give you a switch on both. So that's how the UPS mode in here actually works, and it's a little different than the other devices. You've got a 0 millisecond on this side, and you've got a 20 millisecond on this side, switch over time. That's assuming you're charging off 120 volts. Radio frequency interference test. We're going to need a couple different tools for this. The first one is let's figure out where in the RF spectrum the noise given off by the solar generator is. All devices are going to give off noise. And the other important thing to remember is that I'm in a room that's not RF shielded while I'm recording this. So there is random RF noise going through the air right now that is being picked up by my little meter here. So I'm picking up on this meter. This is a tiny spectrum analyzer, tiny SA is the device, and it is set to 0 to 30 megahertz. So I'm going to pick up the what's considered the HF bands, and then I'll set it to higher frequency after this. But first, let's see what kind of noise we're actually getting in the room with nothing turned on. Now, while we're watching the meter up close, I'm going to turn on the Apex 300. Turn on. There we go, we're on. Basically no change. And let me hit the AC power button. I'm not seeing a whole lot of difference. Yeah, not a lot. I would say as far as AC noise, it's relatively quiet. Now run and grab the AC charging cable. And let's turn on the AC power. See if it makes more noise when it's charging. A little bit more over here. In fact, you can see the levels all across just went up a little bit. So yeah, it makes some noise while charging on the HF bands anyway. Let's turn the charging back off. And let me switch to higher frequencies. All right, now I have it set for between 30 megahertz and 5 gigahertz. We can see on the little progress bar, it actually takes a little bit to do a full pass. So this right here is what the room looks like without the solar generator running. It's turned off right now. This is just my background noise. See, I've got a few spikes here. You know, this is 5 gigahertz over here. It's probably around 2.4 over here. So these are your Wi-Fi bands. You've got some communications channels in the middle, and you got some like RF noise. Those are probably coming off power supplies. So let's turn it on and see what happens. So I'm going to turn on the Apex 300. There we go. Got it powered up. Let's turn on the AC output. AC output is now on. Didn't really change when they turned on the AC output. I don't see much change at all. Let's turn on the charger. There we go, now it's charging. See a little bit more noise down here. That's where you tend to hear power supplies. Sort of in the 30 to 50 megahertz area. But other than the kind of expected noise, we're not seeing any sort of broadband noise here. You know, it seems to be behaving pretty well. So I wouldn't say there's any serious offenders here. The previous test told us where most of the RF interference is, which in this case is usually below 30 megahertz, which is true for pretty much all power supplies. This next test is going to tell us the strength of the RF interference. And we're going to use a meter like this, which is in volts per meter. So before we use this, there's a bunch of videos where you're going to see folks using meters like this where they're not using the meter properly. So let's cover what you actually have to do here. On the screen now you see a chart. This comes from the FCC with the maximum permissible exposure. That is the amount of RF exposure that the government has decided is definitely safe for humans. And there are several columns there. We're going to look at the ones that's in volts per meter because that's the same thing this meter is calibrated in. And you'll also see that there's a bunch of places where I have to divide by the frequency, which makes things more complicated. But effectively, there's 2 units. Let's take worst case scenario. It works out to 61.4 volts per meter for 6 minutes in controlled environments, in other words, people that know that they're being exposed, or 27.5 volts per meter for 30 seconds, or excuse me, for 30 minutes, not 30 seconds, 30 minutes, for people that don't realize they're being exposed. So you'd have to be in an area above 27.5, and you'd have to be there for more than half an hour before it becomes an issue. Or you'd have to be in an area greater than 61.4 for more than 6 minutes. So that's how the system actually works. Additionally, the way to measure it, the meter needs to be about 20 centimeters away from the device. Okay? And this is true in all of this sort of exposure testing, cell phone testing, etc. If you're holding the meter right up against the device, that's not actually a valid test. You have to hold it about 20 centimeters away. So background noise, I'm getting about 3 volts per meter with the Apex here is not even turned on. So it's off. So let's go ahead and switch hands and turn this on. There we go. Power up. Basically nothing. Turn on the inverter. A little bit of a peak right when it turned on. We've moved up to 3 being our peak. And that's it. So definitely safe for humans to be nearby these things. We are nowhere near the maximum of any of it. For my next test, I have had someone ask me whether or not the Apex 300 or other solar generators causes radiation. And radiation tends to mean, yes, do you have a Geiger counter? And I do. So this is a Geiger counter, and we already have the Apex 300 turned on. You can hear it's clicking every now and then. That's just background radiation. That's perfectly fine. You can actually see the scale here is all the way down at the bottom. Hold it up to it. Yeah, nothing. Yeah, solar generators, not radioactive at all. Still all the way down at the bottom. All right, next let's talk expandability, because the entire point of this system is to be able to make it huge or small, depending on what you need, by adding in more or less parts. So the Apex 300 can support several different kinds of expansion batteries. They will be selling the Apex 300 with a combination of B300K batteries, where you can use the same connector cable that they've been using since the AC200 Max. Same thing here, sticks out the side about 4 inches, and hangs off the side, gives you sort of an octopus look. Or alternatively, if you buy the B300K battery with the Apex, they will send you this connector instead, much smaller, where this fits the battery expansion port on the Apex to the battery expansion port on the battery, like that. Let's flip the lock switches, which they still have. You have to make sure the lock switches are both locked. You can power it on, and it should power up the battery with it. There we go, it worked. And it's going to find the battery and then kick in for a different percentage because it found a battery. You can plug up to 6 of these in. Now we're getting even taller. You can also put in mixed mode. I have a B300S battery and a B300K battery all plugged in together. You'll notice my cables are in kind of a funky order here, because in order to connect the B300S batteries, you must have at least one of the P090D to P150D connector converter cables, because these have the 90 amp ports and these have the 150 amp ports. And by the way, this one has the 90 amp ports. So in some point in the string, you're going to need a converter cable. And by the way, if you've got multiple different kinds of batteries, if you're putting in a B300 and a B300S and a B300K all in the same unit, which I don't have a B300, so I can't show you that. But if you want to do all 3 of those, you may need 2 of these connector converter cables. So make sure you get enough of those if you're going to use the B300S batteries. Power this guy up. Finds both of these, finds this one too. Sweet. So it does in fact work in a mixed mode. What Bluetti tells me is if you are using 4 or less batteries, then it doesn't matter what order they're plugged into. B300, B300K, B300S. Doesn't matter at all. Order can be whatever if it's 4 or less. If it is up to 6 and 4 of them are B300 batteries, the original B300s. The B300s only know how to address up to 4. So those ones need to be closer to the head unit. In other words, let's say you have 4 B300s, then a B300K. You'd need the Apex 300, 4 B300s connected in that order, and then below those you'd have the B300Ks. And the ordering only matters if you're using the original B300 batteries. But the B300K, B300S, B300, they all mix and match. They all work together. Up to 6 per Apex unit. So that gives you, what does that work out to? 18 kilowatts? A little bit more than 18 kilowatts per unit. Kilowatt hours, excuse me, per unit. As an aside, folks, these batteries are heavy. Get your friends to help you put them up on the table. Let's say instead of scaling vertically by adding more batteries, we want to scale horizontally by adding more head units. What would we need to do that? Well, Bluetti makes a device called the Hub A1 that adds more head units. Why would you want more head units? Because your load is too high. If you consider 240-volt appliances in the US, they tend to be 240 volts to keep the amperage on the wires in your wall lower. Why? What does that mean? Well, it means they're using a lot more power than you'd want to pull over a 120-volt circuit. So it's not uncommon for a 240-volt appliance to be too big for a single Apex 300 to run. An electric dryer, as an example, the old school electric dryers, the ones that just have heaters in them, not the new ones with compressors in them. But the old school ones, I mean, you're looking at 5 kilowatts for a dryer, just for the dryer. Electric water heater, same idea. Unless you're looking at the new ones that have the compressors in them, you're looking at probably 5 to 8 kilowatts for an electric water heater. One of these isn't going to do the job. So you'd hook it into a Hub A1. Well, I don't have a Hub A1. They just weren't available for the review cycle. And my understanding is there aren't actually enough Apex 300 head units in the country right now for Bluetti to be sending out more than one of them per reviewer. Even as a loaner, they won't loan me one either. So the parts are just not available to demo the Hub A1 working at this time. If that changes, I'll make a video on them, but it is what it is. So what kind of wattage can you actually expect out of a horizontally scaled system? So let's look at the AC200L as a baseline. AC200L has no L2 wattage. What I mean by L2, remember that the US split phase power has an L1 line and an L2 line for split phase. AC200L doesn't do split phase, so your L2 is 0. Apex 300 in 120 volt mode, you can get 3840 watts on L1 and nothing in L2. By the way, the Hub A1 doesn't work in 120 volt mode. So if you just have a 120 volt appliance that pulls 6,000 plus watts, you're not going to be able to take 2 Apex 300s, hook them up with a Hub A1 and switch it to 120 volt mode. It just disables that mode entirely when you're using Hub A1. So yeah, that's not going to scale. Apex 300 and 240 volt mode. With a single one, you get 1920 watts on L1, 1920 watts on L2, and 3840 watts total. With an AC 300, this is comparing to Bluetti's other models. The AC 300 itself doesn't do split phase with 1 unit, but 2 of them do. So 2 units in split phase gives you 6,000 watts total, which is, by the way, bigger than a single Apex 300. So a single Apex 300 is bigger than a single AC 300. But 2 AC 300s is bigger than 1 Apex 300. But, of course, 2 Apex 300s is bigger. So if you put 2 of them with Hub A1, now you're getting 7,680 watts, 3840 per line. You can put 3 Apex 300s to get 5,760 watts per line, or 11.5 kilowatts roughly, which is bigger, by the way, than 2 AC 500s. So the Apex 300 can either be slightly bigger than a single AC 300 in 120 volt mode, or 240 volt mode, smaller than an AC 300 per line, or it can be bigger then a split phase AC 500 unit, depending on how you have things hooked up. It gives you a lot of flexibility. This is, of course, going off the spec sheet for the Hub A1, which I've been asked not to share the manual, but I'll show you a picture of it just so you guys can see that I have actually seen it. And that's going off these specs. I do not have any hands-on with the Hub A1, and I cannot say what it does or does not do or catches to it at this time. If that changes, again, there'll be another video on that. Okay, let's take a quick look at what's changed in Bluetti's app for the Apex 300. Not a lot, but there's a couple things to go over real quick. If you tap on the AC here, it's going to give you both the L1 and the L2 output, two different inverters. That makes sense. Down here, right below that, there's a thing that says components. That's if you've got other stuff plugged into the Apex 300, stuff that hasn't been released yet, honestly. And if I tap on it right now, it hasn't even been fully translated to English yet. I assume they will fix that before it gets fully released. There's the time remaining in the app itself. That's nice. Good to add that. We've got the energy statistics. They've added that. The AC500, AC300, the other devices have that as well. It wants me to set my time zone. That's fine. And let's go to month and let's look at, see, here's all my testing results here from this month. You can see I've actually been using it. So how these statistics work is it actually uploads it to the Bluetti server, and the server then stores the information because the solar generator itself doesn't have any memory in it. Let's go back out of here. That's the same as other devices. Hitting the gear at the top, we've got a few other options here. First off, the Bluetooth connection password. Newer devices have a password you can set so nobody will get into it. Location, you can set where the device is, and so that you don't see my home address, I have it set to the middle of the ocean. There we go. Off the coast of California here is where I told it is. Homepage display sets which device is on the homepage. The working mode, you can set self-consumption, time of use, custom. These are exactly the same as the UPS modes that I cover in my UPS mode video. There is nothing different here. So that's a good video to look at if you want to see how those work. Extreme weather alert. What does this do? This is a brand new feature, brand new to Apex. This only works in the United States at this point. It calls into a US government run, I believe, weather service. And if it detects severe weather coming, it will automatically switch out of whatever UPS mode you happen to be in to grid charging mode, charge it up off the grid fully to get it ready for backup. So you don't have to remember to change the setting yourself, assuming that you're in the United States and assuming that the weather you're worried about is declared severe weather by the government. But it's turned on by default. Charging mode, we have standard, silent, and turbo. By the way, these don't do anything if this switch is set to silent or turbo on the front of the device. The switch overrides the app. There's a custom button down here at the bottom. That lets you change the charging current from 1 amp to 10 amp. Or, by the way, higher if you happen to have a cable that can support faster, but they didn't send me one of those. Okay. Let's go down. We got powerlifting mode, works the same as other stuff. Screen timeout makes the screen turn on and off. Child lock. Here's another new one. Child lock is going to make it so the buttons and the switches on the front of the device don't do anything if your little kids come up and push the buttons. So I can turn it on, and I have level 1 prevents you from turning it off, or prevents you turning it on, and level 2 makes you can't turn it off either. So if you got level 1, you can turn it off, but you can't turn it back on. Level 2, you can't change it at all. Up to you. You can have it on or off with it, regardless of what you need. Firmware update. The firmware update settings have now changed so that they work the same way that the larger devices work. System update here. I'm already up to date. It's actually going to update all 3 at the same time in one button press, which is nice. So you don't have to worry about which order it's going to do it in, it'll figure it out. Pro mode. You can set the AC output voltage, 100 to 120, whether or not you want to be in Japan or not. Let's look at advanced settings. By the way, the reason it said 10 earlier and not 14 is I've got my max grid current turned down to 10. We've got Pro mode turned on here. You can actually set it from 10 up to 50 amps. And the settings above 14 amps, 15 amps I think is the maximum, are only going to work off of the optional cable. So this cable won't go above 15 amps even if you set it higher than 15 in the app. This guy will go up to 50 amps if you set it so that way. Okay, very good. And of course the DC input source you can set either PV or others. Okay? And setting it to others will make it go a little slower in certain areas. And sleep mode, this is another new option. When sleep mode is enabled, even if the unit is sleeping, it will leave the Wi-Fi turned on. In other words, if you turn it off, it doesn't really turn it off. It leaves the Wi-Fi turned on. And it will continue draining the battery for the Wi-Fi, but not very much. But it will completely turn itself off when it hits the SOC that you set, 20% in this case. The advantage of leaving the Wi-Fi turned on means if you're in a remote area, let's say you've got a remote camp where you're not physically going to be there, but you want to control the thing remotely, you can turn this on and it'll stay connected to the Wi-Fi even if it has turned off, and you can remotely power it back on. Super useful. Tons of people have been asking for this. They have finally implemented it. I'm extremely happy. The other one that's in here is the system switch recovery. This is probably the most asked for feature in any Bluetti device. This allows the thing to automatically turn its AC output back on when it turns back on. So if it turns off because of a dead battery and you've got solar hooked up to it, once it charges back up to, I believe, 5%, it'll turn itself back on. And once it charges up a little bit over 5%, it'll actually turn on its AC output on its own and you won't have to go hit buttons. So very widely asked for feature. One of the things I'm somewhat infamous for is doing complete overkill on the discharge testing, where that's not necessarily a bad thing. In this video today, I'll be presenting right around 899 hours of testing across 3 different models, or 37 days, 10 hours, and 53 minutes. Yeah, that's where that came from. If we look at the Apex 300's discharge efficiency graph, let me bring that up. These are not numbers from Bluetti. These are numbers that I measure myself. And in order to get these, each one of these rows is a complete discharge cycle from 100% to 0%. Why do I do that? Well, because the battery meter is not linear. The problem is that the top 10% of the battery meter and the bottom 10% of the battery meter are drastically different amounts of watt hours per percentage. So you can't just discharge it to 10%, or discharge at 10%, in other words, 100% to 90%, and then assume that the other 90% is going to be the same, because you just get incorrect numbers. The other problem is that the way of doing battery discharge is the 0.2C test. Doesn't take into account the fact that this isn't a raw battery. This is an overall total system. So you have to make sure that you are accounting for all of the input, which means you don't really know where the peak power is. And you can see on the Apex 300, it's not entirely smooth. They were actually doing firmware updates while I was doing this. You can see that some of the numbers are a little rough here. And by the way, I didn't actually have enough time to redo all the testing all on the same firmware. So this is across different pre-testing firmware levels. Although you can sort of get the idea from this. So if we go all the way down to 7.5 watts, we're only at 29% efficiency. Why is that? Because the inverters are gigantic. So, but it lasted, 4 days and 4 hours with no power input at that level. Once we get up to about 400 watts, that's where we start seeing real power outputs. And what I mean by 400 watts is I put a constant load. Resistors, light bulbs, heaters, things like that. Things that don't change their power amount usage over time. By the way, heaters, if you're going to use a heater, you got to use one that doesn't have a thermostat so it doesn't turn itself back off. Thermostat heaters aren't going to get you good results. But once you get up to about 400 watts, you're at 86-ish% efficiency. Once you get up to 600 watts, or 700 watts, excuse me, you're at 88% efficiency. And you stay around 88 to 90% efficiency kind of all the way to the end of the curve, which is nice. What that means is the higher wattage part of the graph not having a dip in it. That means their cooling is good enough to keep up. And yes, by the way, the bottom number on the graph, 3,850 watts, I ran this full blow, full rated power, 3840 watts, from full all the way to dead. It took 41 minutes and 10 seconds to do it, and it did not blow the device up. I did that a while ago, and this is the same device you see sitting in front of you. It still works. So the 5-minute test, yeah, you don't run it for just 5 minutes. You can run it full to dead at full power, and it better be able to handle that, or I would not be happy with it. So let's do some comparison with other devices. Let's look at the AC300 and the AC500. I may be the only one that has these numbers, by the way. You can see the AC500 is the least efficient of the three. Of course it is. It has a gigantic inverter, much, much larger inverter. And you can see on the right-hand side of the graph, the tail is longer. It keeps going beyond where the Apex does. Why? Because the inverter can handle up to 5,000 watts instead of 3850. The Apex versus the AC300, they're very close. Very close. The Apex comes out on top a little bit, and the AC300 comes out on top. Now, to make this a little bit more Quagmire-ish, my AC300 test was done with a B300K battery, because I never went and bought an original B300 battery. And by the way, Bluetti does not send me all this stuff for free. I got to buy stuff too. So I never bought a B300. My understanding from Bluetti, their explanation to me of why I was expecting AC300 to be far worse. Their explanation to me of why that is that I used a B300K battery instead of a B300. And the K battery is much more efficient. I don't have data to support that because I don't have an original B300, but it is what it is. But the AC 300 stops at 3,000 watts, where the Apex 300 goes all the way to 3850, or 3840, excuse me. All of this testing was done in 240 volt mode across all of these, and it shouldn't matter which mode I did, because both modes, 120 volt mode and 240 volt mode, both have the two inverters both turned on. At no point in any of the firmware updates that they sent me during testing did they turn off an inverter. So it's the same hardware the whole time. And it shouldn't matter whether or not it's in one phase or another, as far as efficiency is concerned. That said, I didn't have enough time to do another run of this for another 300 something hours of testing to do in 120 volt mode between the time that I had the device and when the video is out. So that's the thing. Last bit on here, let's take a look at the standby power. And yes, again, these are all measured by me. These are all the different Bluetti devices I've measured. Near the bottom of the graph here, Apex 300, third from the bottom, AC standby power, I've got 18 watts. Let's compare that to the AC 500 at 40 watts. So it is less than half the standby power of an AC 500. So if you've got an off-grid situation where you are running from solar and every watt counts, and you don't have anything that needs the giant inverter of the AC 500, you can save half your standby power by switching to an Apex, the Apex 300. Very nice. The AC 300, 31 watts, still a lot. You can save not quite half, save about a third of your standby power by switching to an Apex 300. So if you're in a situation where every single watt counts, the new model is more efficient. They put a lot of work into making these inverters efficient, despite the fact that it's got two of them in there. So that's actually very nice results. All right, we have now spent the past hour or so poking at every test I can possibly think of, including at least one ridiculous test with a Geiger counter, and giving you an idea of how the Apex 300 will behave under use cases. So what do I think of it? The Apex 300 is a series of trade-offs. They wanted to put the battery in the box and have split phase power in the box. That limited them to having relatively small inverters and not fitting some components that otherwise would normally be in the box in there because they just ran out of space. The DC outputs are a breakout box, which by the way will get a separate video. Why is it a breakout box? It wouldn't fit. It's a trade-off. They put a battery in there. Again, the solar controller being a lot smaller. Why is the solar controller so small? Bigger one wouldn't fit. What does that mean? Well, if you've got an RV or a condo, not that big of a deal. If you're putting a couple of solar panels out on the balcony, yeah, the ones that are in here will do the job. You don't need to buy the bigger solar controller. Again, if you've got an RV and you're putting 4 or 5 panels on the roof, the controllers that are in there will do the job absolutely fine. You don't need a bigger one. But if you're doing whole house backup and you want a 3 kilowatt array or a 4 kilowatt array on here, yeah, you're going to need the external breakout box for solar, the Solar X4K. You're going to have to buy one of those or potentially multiple of those. The inverters in the box, there are 2 of them, but they're relatively small. What does that mean? Well, you're probably going to have to buy more than one Apex and link them up together, which is, by the way, the same as what you had for the AC300. Now, this will do, in theory, a better job because it'll balance the batteries better between the different stacks of units. But because I don't have a hub A1 and multiple Apex 300s, I can't actually test that. So people will find out how that works as the product comes out. Is it good for what you need? Well, I don't know. It depends on your situation. It is generally, I think, going to be a good replacement for the AC300. It is dramatically more efficient than the AC300, especially in standby power. If you are running 24 hours a day, 7 days a week off one of these things, the standby power is just eating energy all the time. You are going to save money simply by switching over from an AC300 just straight up due to the standby power. So it's a good change right there. But as far as does it do what you need, hopefully the information I provided helps you with that. So as always, I am not paid to make these videos. I don't work for Bluetti. They don't pay me any money. The channel's not monetized. They don't send me cash. They do have to send me the units because otherwise, this isn't out yet. How would I otherwise you can't get it. So this is a pre-release model. And I do testing on it. A significant number of the things that you've looked at today are stuff that I actually bought, the expansion batteries. They don't send me those for free. I paid for those. And I'm not sponsored by them. So hopefully I can remain reasonably impartial. I make these because I enjoy making the videos, not because I'm paid. I am paid elsewhere in tech, but not solar generators. I don't work on hardware, I work on software. And I make these because they're fun. And if you guys enjoy watching them, and they're fun for you guys to watch and fun for me to make, then I'll keep making them. And we'll all keep enjoying ourselves. So thank you all for coming. Until next time.